Hello and welcome to Lighthouse Project. Today, we are going to talk about bias detection in large language models. We will start by understanding what large language models are and why the topic of bias detection is crucial. Large language models are defined by three main elements. First, large language models utilize large data sets. By learning from vast amounts of text data, they gain a deep understanding of language patterns, grammar, and meaning. These data sets include diverse sources such as books, articles, and websites. Second, the model architecture is primarily based on the transformer structure. Transformers use a self-attention mechanism that enables every part of the input sequence to reference each other's information. Third, high-performance computing resources are essential for training and learning large language models. The combination of these three elements allows large language models to exhibit outstanding performance in various natural language processing tasks. Additionally, the global large language model market is expected to reach $36.1 billion by 2030. As shown in the photo on the right, various large language models have been released. This includes not only closed source models like GPT and Palm, but also open source large language models such as Meta's Llama. Many IT companies are heavily investing in the development of large language models. Currently, foundation large language models such as GPT, Llama, and Palm are available, and there is an active trend of developing domain-specific large language models tailored to various industrial sectors using these foundation models. This trend demonstrates the increasing impacts of large language models on our industry. The positive effects of such large language models include increased efficiency, data analysis, and 24/7 accessibility. Large language models significantly enhance work efficiency by automating repetitive tasks and reducing human errors. Moreover, they help in making better decisions by quickly and accurately analyzing large volumes of data. Lastly, their 24/7 accessibility ensures that information and support are available at any time, maintaining continuity and productivity in operations. However, there are inherent risks associated with large language models. The major risks include privacy risk, bias results, and dependency and misuse. Large language models, due to their training on vast amounts of data, pose a risk of privacy breaches. Additionally, the bias present in the training data can lead to biased results. Lastly, excessive reliance on large language models can result in misuse of the technology and decision-making errors. Let's define what bias is. Bias refers to the tendency of large language models to generate unfair and biased results. This typically arises from imbalances or biases in the training data. Such issues can lead to the unfair representation or exclusion of certain groups or viewpoints, significantly impacting decision-making processes. Representative examples include racial bias, gender bias, and age bias. Racial bias refers to generating negative outcomes for certain races or unfairly favoring specific races. Gender bias results in skewed outcomes based on gender, often leading to unfavorable decisions for women and gender minorities. Age bias produces discriminatory results based on age, either unfairly excluding or favoring certain age groups. These biases exacerbate social inequalities and hinder fair and accurate decision making. Let's explore why bias detection is important. This is because bias in large language models can significantly impact three crucial elements: fairness, trustworthiness, and ethics. Firstly, fairness means treating all users and data equitably. When bias exists, certain groups may be unfairly treated. Secondly, trustworthiness reflects the reliability of the system, and a biased system can lose the trust of its users. Lastly, ethics pertains to ethical standards. An unbiased large language model can make unethical decisions. Therefore, detecting and eliminating bias is essential to ensure these elements are realized. To make it easier to understand, let's examine bias issues by industry. First, in healthcare, large language models predict potential disease based on a patient's symptoms and medical history, assisting doctors in making quicker and more accurate diagnoses. And large language models can automatically summarize electronic medical records and extract important information, allowing doctors to quickly understand a patient's medical history and treatment records, which facilitates efficient and consistent healthcare services. However, large language models can cause two major bias issues: diagnostic bias and medication recommendation bias. Diagnostic bias refers to large language models making inaccurate or unfair diagnoses for specific races, genders, or age groups. For example, certain diseases might be underdiagnosed or overdiagnosed in particular groups. Medication recommendation bias involves large language models unfairly recommending specific drugs or treatments to certain groups. This can result in some populations receiving less effective or more side effect-prone treatments. Secondly, in recruitment, large language models can automatically analyze a large number of resumes and select suitable candidates. This helps recruiters efficiently shortlist applicants by quickly identifying those who best match the job requirements. And large language model can conduct initial interviews through chatbots and evaluate candidates based on their responses. This streamlines the hiring process by providing consistent and objective assessments, allowing recruiters to focus on the most promising candidates. However, large language models can cause two major bias issues: recruitment bias and racial bias. Recruitment bias refers to large language models unfairly evaluating or excluding candidates based on their background, gender, or age. For example, large language models might favor candidates from certain universities or with specific career experiences. Racial bias involves large language models unfairly evaluating or excluding candidates based on their race. This can result in certain racial groups being disadvantaged in the hiring process. Third, in marketing, large language models analyze customer interests and behaviors to deliver personalized ads, ensuring that marketing efforts are more relevant and effective. Moreover, large language model-based chatbots handle customer inquiries, improving the overall customer experience by providing timely and accurate responses to customer questions. However, large language models can cause two major bias issues: ad targeting bias and content bias. Ad targeting bias occurs when ads are disproportionately targeted towards specific genders, races, or age groups. For example, if certain product ads are primarily shown to men, women might be excluded. Content bias happens when the large language model generates marketing content that does not reflect diverse cultures or social norms, potentially alienating various customer groups. Lastly, in finance, large language models can evaluate customers' credit scores and determine loan approval. This helps financial institutions make more accurate and fair lending decisions. However, large language models can cause two major bias issues: credit evaluation bias and investment recommendation bias. Credit evaluation bias refers to large language models unfairly assessing the creditworthiness of individuals based on their race, gender, socioeconomic background. For example, people from certain groups might receive lower credit scores under the same conditions. This can result in certain populations being advised to invest in higher risk or lower return financial products. Next, let's explore why bias occurs and how it can be resolved. The root causes of these bias issues lies within the large language model building process. The large language model building process includes data collection, data pre-processing, model training, model evaluation, model deployment, and maintenance. Firstly, data bias issues can be identified in the data-related process. The main causes of these issues are bias in the data collection and imbalanced data. To resolve these issues, diverse data collection and ensuring balanced data and proper data pre-processing are necessary. Algorithmic bias can occur during the model training and evaluation stages. The main causes of these issues are model design and training methods and hyperparameter settings. Model design and training methods refer to biases arising from the model's design and training approach. Incorrect design or training methods can cause the model to overrun and ignore certain patterns, leading to biased outcomes. Hyperparameter settings involve the value set for the hyperparameters to optimize the model's performance, which can introduce bias. Incorrect hyperparameter settings can cause the model to overfit or underfit certain data patterns. To address these issues, algorithm adjustments and reinforcement learning from human feedback are required. Algorithm adjustments involve modifying the model design and training methods to prevent biased results. Reinforcement learning from human feedback involves using human feedback to improve the model predictions and enhance fairness. The issue of bias in large language models is serious and complex, presenting numerous challenges. Such biases can lead to incorrect decision-making, generate inaccurate information about specific groups, and reinforce social inequalities. Therefore, it is essential to involve various experts at multiple stages. Data scientists and engineers should gather data from diverse sources to ensure representation, enhance data quality, analyze and adjust for bias, and provide accurate labeling and annotation to prevent biased learning. Machine learning engineers and researchers need to design model structures to minimize bias, monitor and adjust the training process in real time, and evaluate and correct for bias through various tests. Ethics experts, legal experts, and fairness tool developers must examine ethical issues and propose solutions, develop policies to ensure fairness and transparency, ensure adherence to legal standards in data usage and model deployment, and develop and maintain tools and frameworks to measure and improve AI fairness. Users and feedback providers should report issues and bias response experienced by users. Have diverse users test the model to identify problems, and engage in discussion within the user community to continually improve performance and suggest improvements. This combined approach will effectively address the bias problem in large language models and contribute to building fairer and more reliable AI systems. Look forward to the upcoming Lighthouse Project Season 3 videos. And thank you for watching. See you next time.